Next, we consider how you can connect components in a circuit that's beyond just a simple circuit. So instead of having just one light bulb connected to a battery, could we have multiple light bulbs connected to the same voltage supply? So the first type of connection that we consider is a series connection. So there's actually two ways of connecting components. You can connect them in series, and in this case, devices are basically connected one to the next in a straight line. And then you can have parallel connections where the devices are both connected, where all the devices are connected together on both sides, kind of like a ladder. So we'll see some examples of that. So here's an example of a simple series circuit. In this particular case, the switch is opened, but I have a voltage supply. Here's my battery, and the wire goes from one end of the battery, connects to one end of the light bulb holder, light bulb screwed in, other end of the light bulb holder, and then to the next, and so on, and then back to the switch, and then back to the other side of the battery. So when the switch is opened here, all of the light bulbs are actually not lit, right? Because there's not a complete circuit, there's no way for the electricity to go across that switch unless it's closed. So there's only, in a series circuit, there's only one loop for the current to go through. And remember, the way that the light bulb holder works is the current would enter maybe through the tip, go up through the filament, and then come out the base, and then it would continue to do that through each one. So it's and here's I guess a better representation. Current comes out, goes in. This is not a good picture because there should be a base, but it goes in through the filament and then out, where this is like the light bulb holder here. All right, so we could ask a couple of questions, and we're going to actually look at the questions. I think we'll answer the questions, and then we'll look at the actual simulation, the Phet simulation. So here's a simple circuit in the Phet simulation where I have my battery, I have some wires, and then I have two light bulbs that are connected. And the question is, how does the current through each of the components that are connected in series compare to one another? And the answer is that there is only one circuit, so that the current can come out of the negative end. If you think about the electrons moving, it's going to go up through the filament, come out, go up through the next one, out and around until it comes back again. So the answer is that current through components that are connected in series is always going to be the same. There's only one loop, and the current flows through that loop, and so all components that are connected in series always share the same current. How does the voltage across each component compare in series? So if we think about Ohm's law, V equals IR, all of the components have the same current. So the I value for each of these components, both of these bulbs, is the same. The bulbs do not necessarily have to have the same resistance. And so if their resistance value is different, then V equals IR, current is the same, resistance is different, the voltage could be different. So each component has the same current but may have a different voltage. The voltages can be the same if the resistance values are the same. So if these are identical bulbs, then they would have exactly the same voltage. But what has to be true is that the voltage of the bulbs has to add up to the voltage of the battery. So for example, if this was a 6-volt battery and both of these bulbs were identical, each one of these bulbs would have to get 3 volts because the voltage has to add up. What happens to the brightness of the bulbs as you add additional bulbs in series? So it turns out the brightness of the bulbs is going to be directly related to the current in the bulbs. So if the bulb dims, this means that the current has decreased, and if the bulbs become brighter, this means that the current has decreased. And so it turns out that the brightness of the bulbs decreases as you add additional bulbs in series. And this implies that the current also decreases. Now, according to Ohm's law, current and resistance are inversely proportional to one another. So as you add additional bulbs in series, the current goes down, the resistance goes up. So the total resistance and the total current are inversely proportional to one another. So let's go ahead and let's try this in a simulation. So here's the Phet simulation, and I've gone ahead and built it. Basically, you can grab the wires and pull them over. You can grab the battery and pull it over. You can double click on any of the components and you can change the voltage. So right now the voltage for the battery is 50 volts. And each of these light bulbs are identical. They each have a resistance of 10 ohms. So I'm going to go ahead and I'm going to close the switch. The brightness of the bulbs is related to the lines that are coming out of these bulbs. Let's sort of separate them a little bit here so we can see it. And they seem to be the same brightness. I can measure the current through the circuit by using this ammeter, this current, and you take the crosshairs and you put it at any location in the wire. So if I put it here, the current is 2.5 amps. If I put it in the bulb up here, it's 2.5 amps. If I put it in this bulb, it's 2.5. Every place in the circuit, the current is the same. So components that are connected in series will always have the same current flowing through them. On the other hand, the voltage does not necessarily have to be the same. So here is a voltmeter. And the way the voltmeter works is you put the voltage, you put the terminals of the voltmeter across whatever component you want to measure the voltage of. So I'm going to go ahead and I'm going to do that. I put it across the battery. The battery measures 50 volts, which is what I expect because that's what I set it at. If I put it across one of the light bulbs, because these are identical bulbs, that 50 volts has to split evenly between them. So this one is 50, and then if I come over here and I put it across just a single bulb, it's also 25 volts on that one. Now, let's think about what happens if I change the resistance of one of these bulbs. So I am going to, I'm going to open the switch, and I'm going to take one of these light bulbs. I'm going to take this light bulb here, and I am going to double the resistance. So I'm going to make this one 20, maybe, while this light bulb is 10. So they no longer have the same resistance. So I'm going to go ahead and I am going to close the switch. And one of the things that I notice is that the current has changed, right? It's not 2.5 anymore because there's now more resistance in this circuit because I have more resistance in this one bulb. But no, still, no matter where I go, the current is still always the same value. All right, now let's check the voltage. So I had this 50 volts battery. It's still 50 volts, but the bulbs are no longer the same. So they don't have the same voltage across them anymore. The bulb that only has a resistance of 10 ohms has less voltage because Ohm's law says V equals IR. The current I is the same, but the resistance in this bulb is less. And the resistance in this bulb is more, so it gets more of the voltage. And of course, the brightness is different now. You can definitely tell that this bulb is not as bright as the other bulb. All right, let's try something else. Let's go ahead and put this back to 10. All right, so we can look at and think about the brightness of the bulbs here. Now I'm going to add another bulb. Well, let's do this too. Let's see what the current is, right? So the current is 2.5. So let's go ahead and add another bulb. So I can disconnect here. And by the way, if I just disconnect, that's like unscrewing the bulb. So I have now unscrewed this bulb from the circuit and both of the bulbs went out. So now I'm going to grab another bulb and I'm going to put it in the circuit. You have to make sure that when you connect the wire that you get a connection from one side of the bulb to the other side in order for them to be lit. So hopefully you can tell that the brightness of the bulbs, when I add additional bulbs, it has decreased. They are not as bright and the flow of electricity is less. So if I come over here, the current is now less than it was before. So if I continue to add additional bulbs, and I don't know that I can do this again, but I'll try. We add another bulb to the circuit, another wire. Whoops. Okay, so this is what can happen. This bulb here is not lit, and you can tell the electrons are not going through. And that's because when I connected the wire, I connected both ends of the wire to the tip and not to the sides that I needed to connect. So one side has to go here and one side has to go here. And now they're even more dim than they were before, right? So the current is even less. So what we learned here is actually working in our simulation, right? So current staying the same, voltage across the bulbs does not have to be the same if the bulbs have different resistance values, but the bulbs' voltages have to add up to the battery. And as I add additional bulbs, the resistance in that circuit is going to decrease. So it turns out that if we're analyzing a circuit that has components that are connected in series, that it's often easier to look at this circuit and analyze it by taking a circuit that has more than one light bulb connected in series and replacing it with a total equivalent circuit. So here I have two light bulbs which may have the same resistance value, or maybe they have different resistance value, and they're connected to a battery. And it turns out that this circuit is equivalent to a single total resistance in the circuit connected to the same battery. The only way that these are equivalent is if this total equivalent resistance is just the addition of the resistance of those two bulbs, because then the current that comes out of the battery will be the same in both cases. So suppose that we had a problem where we had two light bulbs that were connected in series to a battery. So in our case, we have a 20 ohm light bulb resistance connected to a 30 ohm light bulb resistance, and then they're connected to a 30 volt battery. And we want to fill in this table below. We want to determine what is the voltage across each of the bulbs and what is the current in the circuit. So there's some steps that we should follow. The first step is to take this picture which has multiple bulbs and make it and find the equivalent of one total equivalent resistance. So we know that the total resistance in this equivalent circuit is just the addition of the resistance of the bulbs that are connected in series. So 20 ohms plus 30 ohms is equivalent to 50 ohms. So that means that this total resistance here in this circuit, which is equivalent to this one, is 50 ohms. If I know what the voltage is of the battery and I know the resistance, I can solve for the equivalent current in this picture. So current is the voltage over the total resistance. The voltage is 30 volts. The resistance is 50 ohms. So the current that comes out of the battery has to be 0.6 amps. I drew the picture here for the conventional current, which is the current coming out of the positive side of the battery. If I drew the electron current, it would be in the other direction. Once we know what the current is in the circuit that is the equivalent circuit, we also know what the current is in the original circuit, because the current that comes out of the battery in our original circuit flows through each of the lamps and then back to the battery. So if it was 0.6 coming out of our equivalent circuit, then it has to be 0.6 that goes through both of the bulbs. So essentially, the current is equivalent, and so if you find the current through the equivalent circuit, that has to be the current through our original circuit coming out of the battery, which means it's the current through each of the bulbs. Once we know the current through each of the bulbs, we can apply Ohm's law and we can figure out the voltage. So the voltage through bulb 1 is just the current, 0.6 amps, times the resistance of 20 ohms. So 0.6 times 20 is 12 volts. And the current through bulb 2 would be the current, which is 0.6 amps, times the resistance of that bulb, which is 30 ohms, which is 18 volts. So bulb 2 has more resistance, like we saw in the previous picture with the Phet simulation, and therefore it has a greater voltage. But the nice thing is that if I add these two voltages together in series, I have to get the voltage of the battery. And 12 plus 18 is 30 volts. There's another column here for power. We haven't talked about power yet. We're going to talk about that later, and we'll come back and we'll fill in the rest of that table at a later point using the information that we have for this series example.